So I like to start with connective tissues actually because connective tissues are pretty easy to find, unlike some of the other types of tissues. That's because many times, depending on the organ you're looking at, the bulk of the tissue will be connective tissue. Now let's take a look real quick here at our first one. Our first one is part of what we call the connective tissue proper. Connective tissue proper. And there's actually 5 types of connective tissue proper. There's dense, there's adipose, there's reticular, there's elastic, and there's areolar. And we'll go through all of these fairly soon. Notice that I just sort of spelled out the name DARIA: dense, adipose, reticular, elastic, and areolar. And we're going to go through each of these as we go here in the program. All right, so dense regular connective tissue looks a little bit like a highway to me. It looks like there's little cars traveling down the highway here. Notice that all connective tissues have a matrix, and that's the space between the cells. The cells we're looking at here are fibroblast cells. Now these are going to be found in the tendons and ligaments. There's an irregular form, however, and let's take a look at that. The irregular form of dense irregular connective tissue, I should say, would be the skin, for example, and also the periosteum of bone. Look how haphazard this is. It looks a little bit like cheap lunch meat. And take a look over here. These are nuclei here. These are fibroblasts, but they're kind of few and far between, and that's fairly typical for dense irregular connective tissue. Again, this very haphazard pattern. The next one is adipose tissue. Adipose tissue is fat. Fibroblasts gone wrong, at least some of us think that. Fibroblasts will essentially become adipocytes, and those are cells that will absorb fat. This actually resembles, say, marshmallows or bubbles. Some people would say chicken wire. And let's take a look at this a little closer. Now you can see that this big cavity here, this large vacuole, is in effect empty. And that is because during slide preparation, unless you prepare the slide specially, you're going to lose all the fat. So we have an empty space here. And here would be, sort of tucked to the side, would be the nucleus of the cell as well as the cytoplasm. The next tissue is reticular tissue. This is tissue found in the lymphatic organs, also in the liver, and to some degree, obviously, the spleen is lymphatic, so it'll be found in the spleen as well. Here we're looking for some very small threads. See this sort of thready tissue here? These threads are created by cells called reticulocytes. In the lymph node here, the majority of these roundish cells are going to be lymphocytes. But no matter what tissue you're in, look for these very, very, very fine, wispy threads. Let's take a look at a different stain. This is a silver stain, if I recall. And here is the reticular tissue again. Here's reticular tissue right here, right? And some more reticular tissue here. This actually happens to be a reticulocyte. Again, this is from the lymph node. Elastic tissue is tissue that we find in the lungs and then in the skin. But in blood vessels, particularly blood vessels like the conducting artery, we find them in sheets called elastic lamina. The dark lines here represent the elastic connective tissue. So really dark lines. Some people say this resembles tree bark. Other people say tire tracks. Areolar connective tissue looks like flies in a spider web to me. This is abundance of different types of cells. We're not going to get into it now because this is PDQ, but nonetheless, you can see that we have some very thin dark lines here, which are elastin, and then the more thick lines here are collagen. So let's go to this little higher magnification. So collagen and elastin together. We're going to find this in fascia. We're also going to find areolar connective tissue in places like the mesothelium. Areolar connective tissue is also the typical tissue that we find below epithelial tissue. So it helps to make the basement membrane. Most of the time, when you're looking at the underlying connective tissue of epithelium, it'll be areolar connective tissue. Okay, let's quickly go to bone. basically two types of bone. Compact bone, which people say resembles tree rings, if I can say that without Elmer Fudd dialect there. And this is cancellous bone. Let's go back to the compact bone. Compact bone has what we call osteons, and those are these circular structures with a central canal in the middle that houses blood vessels. By contrast, cancellous bone is made of little bony wafers called canaliculi. So that's this kind of pink area here in the middle, right? And so you can see these two different types of bone. Finally, we have cartilage. Cartilage cells look a little bit like fish eggs to me. So if you can see the matrix here, this wonderful matrix, this is a nice glassy matrix in this case. This is hyaline cartilage. We find this cartilage in the ribs, the nose, and even the joints, so at the ends of the joints on diarthretic joints and bones. This is elastic cartilage. Elastic cartilage is similar, again, that fish egg appearance, although notice that the matrix is going to be rich with these long and sort of mesh-like fibers of elastin. We also see these nice droplets of fat in the middle of these cells. So that's another way that you can distinguish elastic tissue from hyaline, elastic cartilage from hyaline cartilage. The last cartilage is going to be fibrocartilage. Typically in fibrocartilage, the cells are linear, and when the cartilage is aged, we also see kind of a fibrous appearance to the matrix. So this looks like a little bunch of fibers all coming together to form a matrix. Young fibrocartilage, however, is very, very smooth, looks very much like hyaline cartilage. And there you're going to be looking for the linearity of the chondrocytes. Well, that should about do it now for the connective tissue. So we'll go to the next one. Thank you.